All right, guys, I hope you enjoyed your weekend. Um, Today we're starting into Unit 12. This will be our last chapter. Um, it's on probability. Um, Today we're doing 12.1 set notation and introduction to probability. Um, this unit can be fun. It's unfortunate we can't be together to do this, but let's just go ahead and get started. So we're going to start by talking about something called set notation. This is going to help us have a discussion about probability, so it's kind of just a starting point. But let's just start by defining what is a set. Okay, so a set, kind of informally, is just a group of things or a group of items, group of elements. Okay, we could say more formally, it's a collection of distinct elements. Collection of distinct elements. Okay, so let's get some examples of sets here. Okay, so an example might be the set of even numbers between 1 and 10. The set of even numbers between 1 and 10. Another example might be the set of numbers between 1 and 5. I'm not going to write that one down. Another one might be the set of appliances in my kitchen. Okay, so it doesn't have to be numbers. It's just a collection of things. Of course, when we're talking about math, a lot of times we're talking about numbers. Not every time, but a lot of times. Okay, so a set is just a collection of items or numbers or things, okay? So let's talk about set notation. So if we have a set of something, we usually put its elements in curly brackets. So for example, the set of even numbers between 1 and 10, we would write it down as curly brackets and then all the numbers between 1 and 10. Pretty straightforward, right? Okay. If I were doing the set of appliances in my kitchen, I would write that down as my toaster, my fridge, my oven, my microwave. Okay. Of course, I may have more, but I'm just going to stop there. So this is what it looks like to write out a set. You have to use the curly brackets. That's set notation. That means this is a set of elements. This is a set or collection of things. Usually we name sets, and usually the default is to use a capital letter to name your set. So for example, I could say that set A is equal to the set of numbers between 1 and 10. I could say set B or C, or I could choose any letter I wanted, but let's say set B is equal to this set of appliances in my kitchen. Okay, that's just kind of a standard default notation. We just use a capital letter to say this is what set I'm talking about. Okay, a sample space. A sample space is, sorry, let me get there. Okay, a sample space is the set of all possible outcomes. All possible outcomes in a probability experiment. So for example, if I were tossing a coin, the possible outcomes would be heads or tails. So the sample space for tossing a coin would be heads or tails. The sample space for for throwing a six-sided die would be that my die could land on 1, 2, 3, 4, 5, or 6. So this would be the sample space, or the sample set would be all the numbers 1 through 6. So the sample space just has to list every possible outcome of whatever experiment I'm doing. Okay, a subset. A subset is a set that is contained entirely in another set. Set that is contained entirely within another set. So in other words, it's not a subset unless all the elements that are in this set are in the bigger set. Okay, so for example, a subset of the set of possible outcomes for rolling a die could be the set 1, 3, 5. Okay, 1, 3, 5 is a subset of this sample space of rolling a six-sided die because 1, 3, and 5 are all within the bigger set. Okay, so this is a subset. So let's call this set C. Okay, so this is a subset of C. Okay. Whereas 1, 3, 7, okay, this is not a subset of C. Okay, this can't be a subset of C because 1 and 3 are in C, but 7 is not. So because 7 is not in C, then 1, 3, 7 is not a subset of C. So it's basically just a smaller set within the other set. So in order to check if it's a subset, you would have to see if every number that's in our new set is also in the sample space, okay, or the bigger set, whatever that is. So the notation for a subset is a sideways U, looks like this. And so the way we would maybe write this is we could say, is A subset of B? Okay, so this is asking, this is how I would read this. I would say, is set A subset of set B? So this should be a yes, no, or no question. The answer would just be yes or no. So if we're looking at the sets that we have written up here, if I look at set A, it's the numbers 1 through 10. If I look at set B, it's the collection of appliances in my kitchen. So A cannot be a subset of B because the elements in A are not in B. So this would be no. Okay, so let's call this set, this 1, 3, 5, let's call that set D. Okay, so I could ask, is D a subset of A? Okay, is D 1, 3, and 5 a subset of A? Well, yes, because 1, 3, and 5 are all in set A. So D is completely contained within A. So I would say yes, it is. Okay, so that's what a subset is. An empty set. Okay, it's denoted with a circle with a line through it. This means a set with no elements in it. Okay, so if we have an empty set, that means it's a set with no elements in it. And we usually use this symbol that's like a 0 with a line through it. So it doesn't mean the same thing as 0. It's slightly different. It means it's a set with no elements in it. Okay. All right, an intersection of sets. Okay, an intersection is denoted, put these in parentheses maybe. This one was, subset is the sideways, kind of a sideways U, kind of ends up looking like a C, but it's a sideways U. The empty set is that circle with a line through it. An intersection is an upside down U like this. Okay, so that's an intersection. And it kind of, the intersection is like is just like an upside down U. It kind of looks like an A without the cross part on there here. But the reason I'm saying that is because it uses this, it means the same thing as and. So if you can remember that upside down U kind of looks like it could be an A if I just crossed it right here, that will help you remember that it means the same as and. And so what the intersection is it is the set of elements included in set, let's say A, and set B. Of course, these could be any sets, right? Depending on what I'm talking about. But it means the same as and. So if I wanted to find an element that was included in set A and B, it would be in the intersection of set A and B. It would be, let's see, how to explain this. Let's say that set A is equal to 1, 3, 4, and set B is equal to 1, 5, 7. Okay, then if I wanted to say take the intersection of these two sets, A intersect B, I'm looking for elements that are in set A and they're also in set B. So since 1 is in both sets, 1 is part of the intersection of A and B. 3 is only in one of the sets. It's not in A and B, it's only in set A. So 3 would not be in A intersect B. Same thing with 4, 5, and 7. So in this one, actually, the only intersection point or element is 1, because 1 is the only one that's in set A and in set B. Okay, so if you're going to draw this as a chart, set A is being this circle, and set B is being this circle. Okay, the intersection is the stuff that happens in here, where it's in both sets. So 3 and 4 are in set A, but they're not in set B, and they're not in the intersection. So they're not in the intersection. 5 and 7 are in set B. 1 is in both sets, so I could put that here where it overlaps. So that's what this intersection is talking about. Okay. Let's make one more set here. So let's say set C is equal to 5, 7, and 9. If I wanted to find the intersection of set B and C, that would be equal to 5 and 7, because 5 is in B and C and 7 is in B and C. It would not include 1 or 9 because 1 is only in B and 9 is only in C. So the intersection is where they overlap. What do they have in common in the two sets? Okay. All right, the union of two sets, that's denoted by a big U, like this, a big capital U. It doesn't have the line down though. And it means the same as or. So if we're talking about a union, we're talking about the set of elements included in A or B. The set of elements included in set A or in set B. Okay, so for example, let's use actually just the same sets from above. If set A is equal to 1, 3, 4, and set B is equal to 1, 5, 7, then the union of these sets, set A union set B, would be equal to any element that's in set A or set B. So 1, 3, 4 would all be here, as well as 1, 5, 7. Now 1 is already in my set, so I don't have to write it twice. I could, it's just not necessary to repeat numbers. But the union would be any element that's in either one of the sets, in set A or set B. So I put them all together, okay? One way that kind of helps me remember this is that this U here sort of looks like a big bowl, and a union is going to take all the elements from all the sets and toss them all together in the bowl, okay? So every element that's in set A or set B is going to be in the union. It's going to be in A or set B. Okay, so if I'm looking at, so this one, the intersection is just this part where they overlap. Okay, if I'm doing a union, I've got set A, 1, 3, 4, and I've got set B, 1, 5, 7. So this is B and this is A. Okay, the union would be all of it, right? Every part of it, whether it intersects or whether it's in the part by itself. The union is all of it together, whereas the intersection is just the part that overlaps, right? The one within here. So that's the difference between the two. Okay, so the last definition that we're going to look at here is called a complement. So the complement of a function is denoted with, well, if my set was x and I put a little c here, this would mean that I'm taking the complement of a set. Sometimes it's written as not in front of x, or yeah, so it would be like not set A or something. Basically, it's the part, it's taking the function and saying everything that's not in it, I guess, that is in the sample space. Okay, so let's write that down. So the complement of a set X okay, so here X is just the capital letter that's denoting which set I'm talking about. So if there would be a set X somewhere, it shows me what it is. And then the complement means I'm taking everything that's in the sample space that's not in X. So it's kind of like the opposite of set X. So let's see how to write this down. The set of elements not complement of set X is the set of elements let's see, sorry, I lost my spot. The set of elements not included in X but still included in the sample space. In the sample space. Okay, so for example, if my sample space, remember a sample space, if you're looking at some kind of probability experiment, is all the possible outcomes. So if we're rolling a six-sided dice, the 1, 6, well, 1, 2, 3. That actually brings up a good point. When you're writing the elements of a set, it doesn't really matter what order they're in as long as all the elements are there. So the sample space for rolling a die is all the numbers 1 through 6. Usually we write them in order just to keep track of them all, but I accidentally wrote 6 next. So this is still a perfectly fine way to write the sample space as long as all of the possible outcomes are listed. They don't have to be in any special order. Let's say that set A, so we're going away from anything we've written up here. Let's say that A is equal to the numbers 1 and 2. So the outcomes of rolling a 1 and rolling a 2. Then a complement, okay, the complement of set A would be equal to all of the numbers that are in the sample space that are not in set A. Okay, so 1 and 2 are in set A, so we would cross those off, and the rest of these outcomes 3, 4, 5, and 6, those are going to be the complement of A. So all the elements that are in the sample space that are not in set A. Okay, so let's say that set B is equal to maybe the even numbers here, so 2, 4, and 6. Okay, then the complement of B would be all the numbers that are in the sample space that are not in B. So basically just look at the sample space and cross out all the ones that are in B, and what's left over is going to be the complement of B. Okay, so that's what it means to have a complement of a set. And there are a couple of other notations for that, but most of the time you'll see that little C. Okay. One other way that it's sometimes written is, up here I didn't notice I did a curly bracket on one side, just getting used to drawing them for set notation. But the other way you can write it is X prime, like this. You just do like a little dash right there. Usually when we see a little dash right there, we call it X prime. But that's another way to write the complement. So you may see either one. So in other words, I could have written this A as A prime like that. I could have written B complement as B, that little dash. So it's just another way to write the exact same thing. So if you see either one of those, that means the complement of the function, okay? All right, so let's look at some examples here. So it says, use the following sets for the questions below. The sample space is the numbers between 1 and 20. The set J is a set of odd numbers. Set K is the multiples of 5 between 1 and 20. Set L is the prime numbers up to 20. And set M is the set containing 1, 10, and 20. So then it's asking us to write out each of these sets. So it says write each set in set notation. So the sample space, if it's the numbers 1 through 20, I need curly brackets because that's what it's saying when it says to do set notation, is that it wants these things written out in a list inside of curly brackets. So sample space is just 1 through 20. Okay, if it's a lot of numbers to write down, we can do dot, dot, dot. That just means we're going to keep going in the same sequence that we started in, and we're going to end in 20. Okay, so that is one way to kind of be a cheater and still write it in set notation, but not have to write every number out. It actually, I mean, if there's a lot of numbers in your set, that might be a good idea. But so that we can actually really see all the numbers in my set, just to be really clear as I'm going through these examples, I'm actually going to write down every number, but I'm just telling you that is an acceptable way to write them if there are a lot of numbers, which there are here, but we will write them out. 16, 17, 18, 19, and 20. Okay, set J is the odd numbers. Now we have to think about this as this is all one problem being taken together. So if it says just set J is the set of odd numbers, it's not going to be all of the odd numbers between 1 infinity or on the whole number line. It's only within our sample space that it's the odd number. So it's going to be the odd numbers between 1 and 20. So 1, 3, 5, 7, 9. None of these will go outside of our sample space, is what I'm trying to say. They're all going to be within this set 1 through 20. Okay, all of these are going to be subsets of the sample space. Okay, K is multiples of 5 between 1 and 20. So 5, 10, 15, and 20. L is a set of prime numbers. So let's look at which ones of these are prime. Remember, prime numbers are only divisible by 1 and itself, and 1 is not considered a prime number. So 2 is a prime, 3 is prime, 4 is not because I could do 2 times 2 as well as 1 times 4. 5 is prime, 7 is prime, 9, 10, 11 is prime, 13 is prime, and 17 is prime. Let's see, and also 19. Okay, so here's our prime numbers between 1 and 20. And then M is a set containing 1, 10, and 20. So here's our sets that we're looking at, okay? Our sample space 1 through 20, these are our other sets. Now we're going to look at and answer these questions down here below, okay? So the first question is M a subset of K? Okay, so remember that sideways U means subset. So is M a subset of K? Remember, a subset is completely contained within the bigger set. So basically another way of asking this is, are all the elements in set M also in set K? Okay, so that's another way to ask the same question. Are all the elements that are in set M also in set K? Is all of M contained in K, right? Is M a smaller set taken out of K is another way to say it. So M has 1, 10, and 20. K does not have 1. It has 10 and 20, but it does not have 1. So the answer would be no. Okay, it is not a subset. Is set L a subset of J? So I look at L and I look at J. Are all the numbers in L also in J? And all of them are, except for L has this extra one too that's not in J. So this is not a subset. Okay. In order to be a subset, every number has to be in the other set. Okay. So those are not subset. What is K intersect M? Okay, so remember A, you can think of it as kind of an upside down capital A. It means the same as and. So these elements have to be in K and they have to be in M. So we're looking for that intersection. Which elements are in both K and in M? So look at K, we have 5, 10, 15, 20. M, we have 1, 10, and 20. So which ones are in both? That would be 10 and 20. Okay. 10 is in set K and set M. 20 is in set K and set M. 1 is only in set M, not M and K. 5 is only in set K, not both, right? And same with 15. So it's only the ones that are in both. Okay, what is J intersect K? Remember that's the same as what is in J and in K. So looking at J and K, they both have a 5. They both have a 15, so the intersection would be 5 and 15. Okay, where do they overlap? What ones are which numbers are in both? Okay. All right, we're gonna have to move down here where we can't see our sets anymore. What is J union L? So remember, it's like a great big bowl. We're gonna toss all the elements of A and all the elements of J all together, and that's gonna be our new set. Okay, so J and L. It looks like we're gonna have 3, 5, 7. We're gonna have most of the odd numbers, or no, we'll have all of the odd numbers, and then including 2. We want all these elements, 1, 3, 5, 7, 9, 11, 13, 17, 19. We want, or all of these were already in the odd numbers that were there, right? But then 2 is included. So it'll be all the odd numbers plus including 2. So 1, 2, 3, 5, 7, 9. 11, 13, 15, 17, and 19. Okay, so that would be the union of those two sets, but all the elements from both sets together. Same with number 6. What is L union M? So we're going to take all the sets of all the elements in L and all the elements in M. We're going to put them all together. So that would be 1, 2, 3. So all the prime numbers, and then include 1, 10, and 20. Okay, so 1, 2, 3, 5, 7. So all the prime numbers. Let me go back up and look. All the prime numbers. And then including, and then add back on 1, 10, and 20. We already did 1. So 10 and 20. Okay, again, remember, it doesn't matter what order they're in. Sometimes it's helpful to put them in order just so that you can make sure you have everything there you need. But the union just means take all these elements from both sets and put them all in together. If one of the numbers, like 13, was in both, no, it wasn't. In fact, in that one, none of them were in both. 1, 10, and 20 was a completely different set than the prime numbers, but we just put them all together in one set. But in number 5, we had some elements, like 1 that was in J and L, but we only need to write it one time when we're doing the union of those sets. Okay. So remember, union is the same as or, and so we're saying these elements have to be in set J or in set L to be a member of our new set. Whereas on the intersection, we can think of it as meaning and. It has to be in set K and in set M to be in our new set. Okay. What is J complement? So that would be all the numbers that are in my sample space that are not in J. So if I go back up here and look, J is all of the odd numbers in the sample space. So I would go through and cross out all the odd numbers in order to get the complement. We wanted to get rid of everything that's in set J and still in the sample space. So it would just be all the odd numbers between 1 and 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, so the complement means look at the sample space, cross out anything that's in J, and then what's left is going to be the complement. So K complement, set K is 5, 10, 15, and 20. So I would go to the sample space, I would cross out 5, 10, 15, and 20, and all these numbers that are left, that's the complement of K. So it would be 1 through 4, skip 5, 6, 7, 8, 9, skip 10. That is not a 9. 11, 12, 13, 14, skip 15, 16, 17, 18, 19, skip 20. There's my complement for K. All right. Okay, now we're going to use what we've learned here to start talking a little bit about some probability. So first, let's start out by just talking about what a probability is. Okay, so a probability is basically written as the number of, so it is the number of ways something can happen. So the number of ways an event can happen divided by the total number of outcomes. Okay, so probabilities are always between 0 and 1, or between 0% to 100%. You can't have a probability that's more than 100%. So, for example, let's say I roll a 10-sided die. Okay. So the total number of outcomes is a sample space, right? If I roll a 10-sided dice, so let's write this out. This is the sample space. I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So that's the total number of outcomes. There's 10 of them, right? If I wanted to know if my event was rolling an even number, okay, then the set of my event would be 2, 4, 6, 8, 10. Okay, so these are all the available, or the number of ways that it can happen. These are the number of ways that I can roll an even number. There are 1, 2, 3, 4. There are 5 ways I could roll an even number. So that's the number of ways the event could happen over the number of the total number of outcomes, which is 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possibilities overall for rolling the die. So that's what goes on the bottom. There are only 5 that are even. So the probability is 5 out of 10, or 1/2, or 0.5. The percentage I would get by timesing that by 100, right? So the decimal would go over twice. So there's a 50% chance I'm going to roll an even if I am rolling a 10-sided dice. Okay. So what if my event were rolling a number greater than 8? Okay. How many numbers are greater than 8? Just 2 of them, right? So there are 2 ways that event can happen out of 10 total ways, total possible outcomes of rolling a 10-sided die. So that would be 2/10 would be 0.2, which would be 20%, a 20% chance. Okay. The back of your worksheet has another one that's going to ask you, it's a little bit confusing, I guess. It's going to ask you if I roll two six-sided die. Okay, so if I'm rolling two dice, that means I'm going to have two numbers that show up on top, right? So in order to write the sample space for this, I have to think about, and actually it doesn't say to actually write out the entire sample space. It says to describe what would happen. But I could have like the first dice being 1 and the second being 1. I could have the first dice being 1 and the second being 2. In order to list these all out, I would have to go in order here, being my first dice being 1 every time and my second die going through 1 through 6. Okay, then likewise I could have my first die being 2, my second one being 1, 2, 3, 2, 4, 2, 5, 2, 6. Okay, so each of these is an outcome, and I could just sit and list all the possible outcomes for both dice. So they have to be both taken together, basically. So this is going to keep going this way, and it's going to keep going this way till I get 4, 1, 5, 1, 6, 1. So basically we have a 6 by 6 grid of outcomes, which means there's going to be 36 total possible outcomes, right? Now, in your question, it's asking that you add the numbers together and get a certain number, like 7 or something. So you would be looking for all of the combinations that you could add together and get 7, like 1 and 6 adds to 7, 2 and 5 add to 7, 1 and 5 adds to 6. So that one would not be included in your possible outcome or in your event outcome. So that's the kind of thing it's asking you. So for example, let's say that it was asking me to find the probability of rolling let's say 5. So we take the numbers on the dice and add them together. Is what this is asking. Okay, if you take the face value of each of the die and add them together and we get a 5. Okay, so 1 1, that's if I add those together, that's going to give me 2. So that one would not be in what it's asking the probability of. 1 plus 2 is 3, so that one would not. 1 plus 3 is 4, so that one would not. Okay, that one would be one of our outcomes that adds to 5 if I add the numbers together. Okay, so I'm going through and I'm finding all the ones that add to 5. Okay. 3, 2, 4, 1. Okay, let's see, would that be all of them? 4, 1, 4, 2, 4. I'm just kind of filling out my charts more. Yeah. So I think it would just be those 4. Trying to think. This one goes 5, 1, 5, 2. Yeah, those are all going to be bigger. So I think it's just those 4. So the probability of rolling a 5, when you're summing both of the die on top, will just be these 4 out of the total possible outcome, which would be 36. Okay, and you could simplify that. So you do that by, if I take my calculator and divide 4 by 36, that gives me 0.111 repeating. Then just times that by 100. So it'll be 11.11%, I guess. Okay, so in order to get the decimal, take the top number and divide it by the bottom number. Once you have the decimal, move the decimal place over 2 times to get the percentage. And this was 0.111111. Like that 1 keeps repeating. Anyway, this was kind of a longer video today, but hopefully your assignment will be pretty quick once you've watched it. So have a great day, guys. Bye.